Get your writing materials. We're starting very late today, but we're going to cover a lot. Yes. Welcome. As soon as you come in, please, let's see your comments. You're all welcome. You're all welcome. You're all welcome. If you can see the board clearly, let us know. If you can see the board clearly, let us know. If you can hear us, let us know. Welcome. Get your writing materials ready. Get down your writing materials and let us get started. Get your writing materials ready. Let us get started. No time to waste. No time to waste. No time to waste. Let us get started. Let us get started. No time to waste. No time to waste. If you are with us, say sir, I'm with you. If you are with us, say sir, I'm with you. You are all welcome. Welcome to the Jamb Master Live Physics class, day 6. Please, you're just joining us. We have done day 1, day 2, day 3, day 4, and day 5. The videos are there. I'll send to you. You watch. Don't worry. All our classes are recorded. So there's no panic in our class. You don't have to panic. You don't have to panic in our class because all our classes are recorded. Let me share the link with you guys on the group, then we'll start. Let me share the link with you guys on the group, then we'll start. You are all welcome to the Jamb Master Live Physics class, day 6. The Jamb Master Live Physics class, day 6. Welcome. Get your writing materials ready. If you can hear me, say I can hear you, sir. If you can hear me, say I can hear you, sir. I can hear you, sir. If you can hear me, say I can hear you, sir. We are all welcome. 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 Let me know so I can get started. Give me a feedback so I can get started. Give me a feedback so I can get started. If you can hear me, say I can hear you, sir. You can see the board clearly. Say, sir, I can see the board. Sir, I can see the board. I can hear you. If you can hear me, say, sir, I can hear you, sir. I can hear you, sir. You can hear me clearly. Say, sir, I can hear you, sir. I can hear you, sir. Welcome, welcome, welcome. Give me feedback and we'll start. Give me a feedback and we'll start. Give me a feedback and we'll start. Give me a feedback and we'll start. Who is with us? Who is with us? Who is with us? Who is with us? Let us get started. Let us get started. Let us get started. Who is with us? Who is with us? Who is with us? Let us get started. Let us get started. Welcome. Miracle Adeyemo, welcome. Ifechuku Faustina, welcome. Welcome, 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 welcome. Welcome, 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 welcome. Welcome. Let us get started. No time to waste. Get rid of all distractions. Get rid of all distractions. Get rid of all distractions. And let us get started. Get rid of all distractions. Get rid of all distractions. Let us get started. Get rid of all distractions. Let us get started. Good evening, everybody. Chinenye Chima, Ulogu Mary, Fatima, Augustina Chigozie. Good evening, everybody. Good evening, everybody. Good evening, everybody. You are all welcome. You are all welcome. Esther, I see you. Good evening. Good evening. Good evening. Good evening. Oh, good evening. Good evening. Good evening. Welcome, welcome, welcome. Okay, let's get the ball rolling. Let us get the ball rolling. Let us get the ball rolling. Yes, 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 yes. Without wasting more time, let us quickly look at Coulomb's law of electricity. Class. This is not a normal class like a secondary school. They'll start teaching you from the give me a story. There's no time. Jamb is very close, straight to the point, hit the nail on the head. So normally if I want to teach electricity in a second, I was teaching in a secondary school now. I will not start from Coulomb's law. I'll first start teaching electrostatics. I'll start teaching the gold leaf electroscope, how charges are generated, you know, via induction, via conduction, you know. I will start teaching you all the electricity signs. What does switch mean? What does key mean? What does cell mean? There are different signs in electricity. Those are your foundational secondary school you should have learned. for class. We cannot waste time because this is a crash class for your exam. Your exam is getting very close. So Coulomb's law of electricity. So we'll just go to relevant topics immediately. Coulomb's law of electricity states that the electric force of attraction. Coulomb's law of electricity states that the electric force of attraction between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. Class, this Coulomb's law. I hope you are still with me. Don't forget our commitment. I will not live to the end. Don't forget our commitment. I will not live to the end. I will not live to the end. Please, if you missed any day of our class, there is a record. Don't worry yourself. If you have missed any day, there is a record I will send to you after this class. You can see here this day 6. This is day 6. So day 1, day 2, day 3, day 4, day 5 will be sent to you. Don't worry yourself. Yes, I can see people already typing, I will not live to the end. Everybody's already typing, I will not live to the end. Everybody's already typing, I will not live till the end. Coulomb's law states that the electric force of attraction between two charges, that you can say 2-point charges, 2 points, is directly proportional to the product of the charges and inversely proportional to the square of the distance between the charges. Class, if you have 2-point charge Q1 and Q2, we say the electrical force of attraction between them is F, and distance between them is R. So R represents the distance. F is the force. According to Coulomb's law, the force F, let's interpret this mathematically. F is proportional to Q1 times Q2, but inversely proportional to what? To the square of the distance, R squared. So F is directly proportional to the product of the charges, but inversely proportional to the square between them. Class, this will imply that F will be equal to K, constant will come in here, K Q1, Q2, all over R squared. F will be equal to K Q1, Q2, all over R squared, where K is known as the Coulomb's constant. K is known as the Coulomb's constant. And it has a value of 9.0 times 10 raised to power 9 Newton meter square per Coulomb square. 9.0 times 10 raised to power 9 Newton meter square per Coulomb square. Class, you don't want to use K as this, you can use K as 1 all over 4 pi E naught. So this K can also be replaced with 1 divided by 4 pi E naught. We all know what pi is. Pi is a constant in physics, which is in mathematics, which is 22 over 7. Pi is 22 over 7, right? Or 3.142. Remember, in mathematics. Now, your E naught, what does E naught represent? This E naught, E naught represents what we call the absolute permittivity. Absolute permittivity. And it has a value of 8.85 times 10 raised to the power of minus 12. Are we still following? Are we still following? I will not live to the end. Get rid of all distractions. I will not live to the end. Get rid of all distractions. Get rid of all distractions. Get rid of all distractions. If you miss any class, don't worry, the videos are there, I'll send to you. If you missed any day, If today is your first time, can you type first time in the comment section? Type first time. If today is your first class with us, type first time. If today is your first time with us, type first time, sir. I just joined, sir. You can see our group, there are a lot of people that have been with us. So Jamb is a very serious program. So we didn't just start today. You can check our group. Some students have been learning with us. If today is your first time, say first time, sir. So I will send you videos of day 1 to day 5. You sit down and watch and study. Are we together? Because tomorrow we are entering a new subject. Tomorrow we are entering a new subject. Tomorrow we are entering a new subject, biology, mathematics, and literature. Biology, mathematics, and literature. There will be 3 different groups. 1 group for biology, 1 group for mathematics, and 1 group for literature. You enter the group that you are offering, for the course you are offering. After this live, I will create the groups and I'll post it on the English group. So you join only the group you are offering. Let us move forward. Class. We say K equals to 1 over 4 pi E naught. So replace this K. Let us replace this K here with what? 1 over 4 pi E naught. What will be left? Q1, Q2, right? Q1, Q2 all over what? R squared. So that F will be equal to 1 times Q1, Q2 is Q1, Q2 divided by 4 pi E naught R squared. This formula also stands for force of attraction between 2 point charges. This formula also stands for force of attraction between 2 point charges. Please note that when Q1 equals to Q2, when the 2 charges are equal, we can call it just Q. What that will mean is that F will now be equal to what? Instead of Q1, Q2 will be Q times Q, right? Because both Q's are the same. All over 4 pi E naught R squared. And Q times Q is Q squared. All over 4 pi E naught R squared. So class, this is the formula for force of attraction if you are told that the 2 charges are the same. If you are told that the 2 charges are the same, find the force of attraction between 2 equal charges. 2 equal, this is your formula. But the charges are different, this is your formula. I hope we are still together. Let's keep going, let's keep going. Class, let's look at electric field. Electric field is a region of space where what? A charged body experiences what? Electric force. Any region of space where a charged body experiences electric force is referred to as electric field. It's a region of space where a charged body experiences electric force. Class, another name for electric field is called electric field intensity. Also known as electric field intensity. Also known as what? Electric field intensity or electric field strength. Electric field is also known as electric field intensity or electric field strength. Class, mathematically electric field E equals to force divided by quantity of charge Q. Electric field E is force divided by quantity of charge Q. Are we still there? Electric field E is F all over Q. Let us proceed. Class. But electric field can also have another formula. Don't forget that if this force was a Coulomb's force, what is the formula for Coulomb's force? We have told you that the force F is equal to K Q1 Q2 all over R square, right? Remember? From Coulomb's law, F is K Q1 Q2 over R square, where K can be replaced with what? 1 over 4 pi A naught. Then you still have Q1 Q2 over R square. But when the two quantities of charges are the same, what will it be? F will be equal to KQ times Q, because they are the same. If they are the same, you don't need to say 1 and 2. If they are the same, you don't need to say 1 and 2. It's Q times Q all over R square. That will give you F equals what's Q times Q? KQ square over R square. So the force of attraction between two charges that are the same is F equals to KQ square over R square. I want to replace this F with KQ square over R square. Don't forget this E represents what class? Electric field. What's that name for electric field? Electric field intensity or electric field strength. And the formula for electric field is force all over quantity of charge. But the force according to Coulomb's law is KQ square over R square. Allow me to replace F with KQ square over R square. I'm going to have KQ square over R square divided by Q. What happens is that this Q cancels one Q here, leaving one Q here. So the electric field E is equal to KQ all over R square. Electric field E equals to KQ all over R square. It's very important in physics that you have different formulas for one quantity. It's not good enough that you just know electric field as F over Q. It's wrong. Just like some students only know that force is mass and acceleration, they don't know any other formula. They only know mass and acceleration, they don't know any other. That's not good enough. Force can also be mv minus u all over t. Force has different formulas. You must know different formulas. Because if you know only one formula and they ask you a question that requires another formula of that same thing, then you'll be lost. This can also hold. Are we still together? Are we still together? Good. Nancy said, right on, sir. Chineye said, yes, sir. Ifechuku Faustina, yes. Rachel Igwe said, right on, sir. This is good. I see you. Well done, class. Well done, class. Well done, class. If you are reading this topic on your own, you won't have gotten here by now, because you'll still be struggling with the first point. What are they saying? What are they trying to say here? So this kind of class helps your preparation to be faster. Remember I told you in our last class, because you are attending a class does not mean you should not be reading. As we are doing our own, be doing your own, be backing up. Okay, they're not supposed to be, let me go and read this one. Be backing up. Iron sharpening iron. As we're working together, you succeed. A student that will enjoy this class, a student is also doing, like, putting in efforts. I made a statement the last time. I said, read as if you have not attended any class. Read as if you don't have any Jamb master to help you. And when you're in the Jamb master class, concentrate as if you have not read. When you're in the Jamb master class, concentrate as if you have not read anything. And when you are reading, read as if you don't have any Jamb master to help you. Now your own, read everything, read. Help yourself too. Do your Jamb past questions. If you're just joining us, we have a rule. Every day you must do 2 years of Jamb past questions. Today you do biology, tomorrow you do mathematics, next tomorrow chemistry. For your 4 subjects, make sure you're doing your Jamb master past question every day. Take 2 years every day. Jamb is getting close. The more you're doing past question, the more you are getting used to have a set exam in Jamb. Every day do 2 years of Jamb past question. Let me tell you, nobody will be able to finish the whole Jamb syllabus, it's too big. Even your secondary school teacher could not finish it. SS1, first term, second term, third term. SS2, first term, second term, third term. SS3, first term, second term, third term. That's 9 terms. And most of you do not see those some topics in physics today. In 9 terms, each term is 3 months. So 9 times 3, 27 months. And you don't still know some topics in physics. You don't still know some topics in mathematics. In 27 months. So class, the best thing you can do is make sure you are reading with direction. Read with direction. If you go to my YouTube channel, you see some top topics in each subject. I did top 10 topics in physics, chemistry, key topics you should study when you are reading. They are the ones that Jamb likes setting a lot. Make sure you are reading. Make sure you are reading. Read as if you don't have any Jamb master class you are attending. And when you come to class, attend as if you have not read. Every day, do 2 years of Jamb class questions. 2 different years every day. If you follow this instruction and you are reading and you are attending my class too, you will smash your Jamb. But if you break any of the rules, you might still not do well. And you will not blame the Jamb master that not teach you well or something. Put in your own effort too. Even if those who help themselves, make sure you are putting your effort. Put in your effort. As we are trying to teach you, you put effort. Every day, 2 Jamb pass questions should go down. Delete your TikTok. If you're a new student here, we have all deleted our TikTok. If you're just joining us, our room, delete your TikTok, delete your every social media, so you can concentrate. Every time is valuable. Every time in this Jamb period is very valuable. No time to be on TikTok for 1 hour. You could have done 1 year of Jamb pass question. Take notes. Because Jamb is so broad, we will not be able to teach you everything in that time, but at least apply the things that are being taught. Apply the things you are telling you to do, you still pass your Jamb. Every day, 2 years of Jamb pass question. Every day, 2 years. Class. We want to go to electric potential. Electric potential is V. Class, electric potential V is equal to the electric field E times distance R. In case you ask me, electric potential V is measured in voltage, volts. Potential is the product of electric field times distance. And class, we just said the electric field according to Coulomb's law is what? KQ all over R square, right? Electric field according to Coulomb's law is KQ all over R square. Now, potential is electric field times R. So times R. Before I continue this class, if I make this sort of formula here, if I make electric field sort of formula here, do you know I have another formula for electric field? Electric field is now going to be equal to what? V all over R. That's 3 formulas for electric field. What's the first formula I gave for electric field? E is F over Q, right? Also E is what? KQ over R squared based on Coulomb's law. Look at 3 different formulas for electric field. Imagine you just know this one. Then I ask you a question based on this. You will not know what to do. In the exam, they say find the electric field given that electric potential is 5 volts, covering a distance of 3 meters. Find the electric field. You don't know that electric field is also V over R. You will be lost. So learn lots of formulas. Physics is about lots of formulas. Let us continue. So please take note of these 3 formulas for electric field. Class, electric potential is electric field times distance R. What's electric field? KQ over R squared times R. Class, R can cancel 1 R here, leaving you with 1 R here. So electric potential is KQ all over R. But don't forget that K is 1 over 4 pi E naught. So Q all over 4 pi E naught R. Don't forget, K is what? Recall. K is 1 over 4 pi E naught. K is 1 over 4 pi E naught. K is 1 over 4 pi E naught. Let's keep going, let's keep going. Let's keep going, let's keep going. Class. Based on Coulomb's law, we also derive electrical work done. Electrical work done normally is force. Work done is force times distance, remember. Work done is force times distance. So electrical force times electrical distance covered. What is force? KQ square over R square, remember. From Coulomb's law, force is KQ square over R square. Now multiply this by R, what will happen? R will cancel 1 R here, leaving 1 R here. So the work done is KQ square all over R. Your work done is KQ square all over R. Please take notes. Now let's look at electric lines of force. Electric lines of force. Electric lines of force are imaginary lines drawn that shows the direction of the electric field. Imaginary lines drawn that shows the direction of the electric field. Imaginary lines drawn that shows the direction of the electric field. Class, they are also called field lines. Field lines. Class, in your exam you could be asked, which of the is not a property of electric lines of force? Which of the following is not a property of electric lines of force? So let's look at properties of electric lines of force. Properties of electric lines of force. Properties of electric lines of force. 1. They start from positive and end in negative. They start from positive and end in negative. 2. They repel each other sideways. 3. Constantly in a state of tension. The electric lines of force are constantly in a state of tension. Causing them to shorten. 4. The number of lines per unit cross-sectional area. Is proportional to the magnitude of the field. The number of lines per unit cross-sectional area is proportional to the magnitude of the field. That's electric lines, that's properties of electric lines of force. The properties of the electric lines of force. The properties of the electric lines of force. So they are called field lines. They are the ones that show the direction of the field. Start from positive and negative. The number of lines determines how large the field will be. The number of lines per unit cross-sectional area shows the magnitude, that's the size of the field. Shows the magnitude of the field. Please take note. Let's go to capacitors. Capacitors. No time to waste. No time to... Capacitor is a device used to store electrical charge. or electrical energy. A capacitor's function is to store charges. Class, what makes a capacitor? We have two metal plates, and in between the two metal plates we have what we call a dielectric. A capacitor is made up of two metal plates with two insulators between them. A capacitor is made up of two metal plates with two insulators between them. The insulators are called dielectrics, class, dielectrics. Class, you know in physics, a material can either be a conductor of electricity or an insulator or a semiconductor. Now, conductors conduct electricity, we all know that. Insulators do not conduct electricity. But semiconductors can conduct or may not conduct, depending on the condition. You could be asked, the example is true of semiconductors. Are you aware that increase in temperature increases the conductivity of semiconductors? Increase in temperature increases the conductivity. Increase in temperature increases the conductivity. Of semiconductors. Increase in temperature increases the conductivity of a semiconductor, while decrease in temperature reduces the conductivity. It means that at higher temperature a semiconductor will conduct, at lower temperature it becomes an insulator. So someone that can behave both as a conductor and as an insulator depending on the condition is called a semiconductor. Please take note. But to form a capacitor, we don't need a semiconductor. We just need two metal plates. What are metal plates? Conductors, right? And two insulators. Who are insulators? Non-conductors. What's the name for insulators? Dielectrics. Insulators are also called dielectrics. Class, the capacitance of a capacitor you can be asked to calculate the capacitance of a capacitor. Class, if a capacitor is a device that is used to store electrical charge or electrical energy, then the capacitance of a capacitor is the capacity of that capacitor. That means the ability of that capacitor to store electrical charge is called capacitance. What is the ability? How much electrical charge, electrical energy can you store? Your ability, your capacity is called capacitance of a capacitor, C. And class, it's a known fact that the capacitance of a capacitor is directly proportional to the area of the capacitor and inversely proportional to the distance between the two plates. Don't forget there are two metal plates, and there are two insulators. Class, without this insulator, the capacitor cannot store the charge. If you only use two metal plates, what are metal plates? They are conductors. Conductors cannot store. They will allow the charge to pass through and go. So the conductor's job is to attract the charge. If you only use insulator cannot attract charge because it does not conduct at all. So the conductor's job is to attract the charge, the insulator's job is to keep the charge. If a conductor allows charge to pass through, insulator keeps the charge. In this way, the two metal plates and insulators work in tandem to store electrical charge, electrical energy. Class, the capacitance of a capacitor is the capacity of the capacitor. That means the ability, how much of electrical charge can the capacitor store. And the capacitance depends on the area of the capacitor plate and the distance, that's the distance between the plate, the distance, D. Anytime you have this sign in mathematics or physics, a constant must come in. This therefore implies that capacitance of the capacitor will now be equal to what? A, what's the constant that comes in? Permittivity. All over D. What does this permittivity mean? I've mentioned it before, it's called absolute permittivity. Class, but it's not every time you are going to use this E naught. Now the value is 8.85 times 10 raised to minus 12. Class, you use E naught if the insulating medium. Remember that to make a capacitor, you need 2 metal plates and an insulator. Insulating medium, right? If the insulating medium uses air, then the permittivity is this permittivity of air. This absolute permittivity also means permittivity of air or permittivity of free space. But class, if the insulating medium used is another insulating medium apart from air, the formula, class, is AE all over D. But there's a big difference between E and E naught. E naught is the absolute permittivity. That's permittivity of free space, permittivity of air. When air is the insulator used, class, you know that air is an insulating medium. It's a very weak insulator, but it's an insulator. When the insulation of this capacitor is dependent on air, class, we use E naught. But when there's another insulator being used, we use E, because E does not have the same value as E naught. E naught is a constant, but E changes depending on the kind of insulator you use. Every insulator has its own permittivity. So E naught is called absolute permittivity, but E is permittivity of insulating media used. Permittivity of insulating media used. Now, whatever insulating medium you use, that's E. So always listen to your question. When they give you a question on capacitance with a capacitor, what insulating medium was used? Take notes before you start solving. Are we still together? Are we still together? Someone said enjoying your class. Enjoying your class. Thank you. Thank you. Who is still with me? Who is still with me? Who is still with us? I will not live to the end. Don't forget. I will not live till the end. I will not live to the end. I will not live to the end. Well done, class. Well done, class. Well done, class. Class, you're hearing of permittivity. What is permittivity? Permittivity is how much electricity does the capacitor allow to, the insulator allow to pass through. How much electricity does the insulator allow to pass through is called permittivity. And I told you we have absolute permittivity, we have permittivity of relative media, we also have another one called relative permittivity. Relative permittivity. Relative permittivity. Relative permittivity is the ratio of the permittivity of the medium to the absolute permittivity. So relative permittivity is E all over E naught. E divided by E naught, relative permittivity. So if we cross multiply here, you're going to have E equals to what? ER E naught. E equals to ER E naught. Meaning that anywhere I see E, I can put ER E naught. I can replace this E with ER E naught. That will be A ER E naught all over D. A ER E naught all over D. To show you how deep physics is, there are some students that have never seen this formula before and they have gone to secondary school from SS1 to SS3. To show you how deep knowledge is, some students have never heard of relative permittivity before. Some students have never heard of relative permittivity before. And they actually went secondary school, SS1, SS2, SS3. In fact, the school fees they paid in one term, first term, you know, is more than this fee, like the money you pay for this class. Just one term, first term. Your school fee, remember your school fee first term, except you went to a government school, a very cheap school. And you have never heard of this before. 3 years in senior secondary science. But even your teachers could not cover everything. But we're going to try our best now. Now that we have looked at that class, the next thing we want to look at now is arrangement of capacitors. Arrangement of capacitors. Capacitors can be arranged in series and parallel. Class, when you have more than one capacitor connected together, there are two major arrangement patterns to arrange capacitors. We have the series arrangement. Class, how do we represent capacitor? This is the symbol for capacitor. This is the symbol for capacitors. This one is not capacitor. You see, these are not, they are not equal, right? This is cell. Now, you can say your cell or your battery. This capacitor 1 and capacitor 2. These two capacitors are arranged in series. This is series. And this is a parallel arrangement. C1, C2. We have series arrangements, we have parallel arrangements. Class, it's important to note that you could be asked to find total capacitance in the circuits when arranged in series and when arranged in parallel. It is called total or equivalent capacitance. Total or what? Equivalent capacitance. Class, when capacitors are arranged in series, the total capacitance in circuit is 1 over CT. We use CT to represent total or equivalent CT, or we use CEQ. CT or CEQ. When capacitors are arranged in series, total capacitance, the formula is 1 over CT equals to 1 over C1 plus 1 over C2. But when arranged in parallel, we add them up, C1 plus C2. When capacitors are arranged in parallel, we just add them up. But when they are arranged in series, we find the inverse. Class, it's important to know that it's not only capacitance with capacitor that is in this circuit. We have the quantity of charge flowing through the circuit. We have Q1 and we have Q2. Then we have total quantity of charge in the circuit. We also have the voltage, the potential difference across each capacitance. Let's call this V1, let's call this V2. So class, there are three major parameters at play in this circuit. We have the quantity of charge Q, we have the capacitance C, and we have the voltage V. Q is the quantity of charge. Don't forget, the capacitor's main job is to store charges. C is the capacitance. V is the voltage. Class, is a well-known fact that the quantity of charge is equal to the capacitance times the voltage. Q equals to CV. Please take note. Q equals to CV. The quantity of charge stored by a capacitor is a product of the capacitance and the voltage. The quantity of charge stored by a capacitor is a product of the capacitance and the voltage. The quantity of charge stored by a capacitor is a product of the capacitance and the voltage. So Q equals to CV. Class, I must tell you something now. Now when capacitors are arranged in series, the quantity of charge in each of the capacitors are the same. Note, I'll come again, note, when capacitors are arranged in series, the quantity of charge in each capacitor is the same. When capacitors are arranged in series, the quantity of charge in each capacitor is the same. Class, let us say that the total quantity of charge in this circuit is 2 coulomb. Class, another thing I forgot to tell you, follow me. Please forgive me, let me go back. The capacitance of the circuit. Capacitance, see, the unit for capacitance is farad. The unit for capacitance is farad. But most times you will see microfarad. What symbol for microfarad? You see the symbol. Class, this is the unit for capacitance. Class, this symbol means micro, this F means farad. This symbol means micro, this F means farad. Class, micro has an equivalent of 10 raised to the power of minus 6. So if someone tells you that the capacitor is 5 microfarad, they are simply telling you that the capacitance is 5 times 10 raised to the power minus 6 farad. If someone tells you the capacitance is 10 microfarad, that is 10 times 10 raised to the power minus 6. Because this symbol here means micro. That is the unit for capacitance. What's the unit for quantity of charge? Is what? Coulomb. C. And the other one, voltage, potential difference, V, is volts. It's important to understand each of them, their units. Now I said no, let's continue. When capacitors are arranged in series, they all store the same quantity of charge. And it's the same with the total quantity of charge in the circuit. When capacitors are arranged in series, they all store the same quantity of charge. And it's the same with the total quantity of charge in the circuit. That is the energy. I will not live to the end. Elijah Goodness, I see you. Esther Monday, I see you. Lima Dawn, I see you. I will not live to the end. Chineye Chima, I see you. I will not live till the end. I will not live till the end. So class, what does this mean? What does this statement mean on the board? What does this statement mean? They say when capacitors are arranged in series, they all store the same quantity of charge. And it's the same with total quantity of charge in the circuit. Class, if total quantity of charge QT is 2 coulomb, total quantity of charge in this circuit is 2 coulomb, be rest assured that the quantity of charge that is stored by this capacitor is 2 coulomb. Q1 is 2 coulomb and Q2 is also 2 coulomb. They all store the same quantity of charge because they are in series. But class, do they all have the same voltage? Because class, let us be clear. This capacitor has its capacitance, has its voltage, and has its quantity of charge. While this capacitor also has its capacitance C2, its voltage V2, and its quantity of charge Q2. What we are saying is that because these two capacitors are in series, their quantity of charge is the same. Q1 equals to Q2. And if total quantity of charge is 2 coulomb, that means two of them are 2 coulomb. So the Q1 equals to Q2 and equals to total quantity of charge in the circuit. So when two capacitors are arranged in series and they have given you the total quantity of charge in the circuit, they have just given you the quantity of charge in each of the capacitors because they are in series. But when they are in series, they store the same quantity of charge. But is the voltage the same when they are in series? No. Class, their voltage is not equal. This is equal, this is not. And it's not also equal to the total voltage in the circuit. But we also have total voltage in the circuit. We have total capacitance in the circuit, total voltage, total quantity of charge. So let's make this clear, class. We have C1, V1, Q1, C2, V2, Q2, CT, VT, QT. Total capacitance, total voltage, total quantity of charge. First capacitance, first voltage, first quantity of charge. Second capacitance, second voltage, second quantity of charge. Class, had it been we had up to 4 capacitors in this circuit, it will have been Q1, V1, C1, this one, 3, 3, 3, 4, 4, 4, and the total as well. I hope you are following. Now I want you to recall, I told you that Q equals to CV, right? Q, quantity of charge equals to capacitance times voltage. Quantity of charge equals to capacitance times. So it means that Q1 equals to C1 times V1. Q2 equals to C2 times V2. And QT equals to CT times VT. Q1 equals to C1 times V1. Q2 C2 times V2. QT CT times VT. But because they are arranged in series, Q1 equals to Q2, right? Who is Q1? C1, V1. Who is Q2? C2, V2. Is it then fair to say that if Q1 equals to Q2, it means that C1, V1 equals to C2, V2? The capacitance of the first capacitor times the voltage of the first voltage equals to capacitance C2 times V2. Are we still together? Are we still together? Lily Jumbo, I will not live to the end. That's good. That's good. Class, you are seeing here that the quantity of charge is the same, but the voltage is not the same. What then can we say about the voltage? The V1 plus the V2 must be equal to total voltage in the circuit. Note, when they are in series, V1 plus V2 equals total voltage in the circuit. Let's look at when they are arranged in parallel. When capacitors are arranged in parallel, they all have the same voltage. Across each of them, and it's the same with the total voltage in the circuits. Class, when capacitors are in parallel, the voltage, if total voltage in the circuit is 5 volts, if total voltage in the circuit is 5 volts, then the voltage here is also 5 volts. Voltage here is also 5 volts. Class, the same potential difference runs across each capacitor when they are in parallel. Recall that when they are in series, who is the same? Is the quantity of charge that is the same. When they are in parallel, is the voltage that is the same. The quantity of charge is different. The quantity of charge is different. The quantity of charge is not the same. So V1 equals to V2 equals to Vt. The voltage is the same. The voltage is the same. Class, energy stored in a capacitor. Don't forget that the main function of a capacitor is to store electrical energy. The formula for energy stored in a capacitor, U equals to the symbol for energy stored in a capacitor is U equals to half CV squared, or half QV, or half Q square all over C. Any of these formulas will go. You see, I'm giving you multiple formulas so that you will not be stranded in the exam. Giving you multiple formulas so you don't get stranded in the exam. Make sure you're writing. Class, it's time to go to resistors. You can see we have never started taking questions yet. So see that the work is big, it's a big work. It's a big work. What would a smart student do? We are giving you the foundations of each of these topics. A smart student will go to all questions on capacitor. Okay, so they have taught me, so this is what it means. Just try taking questions so that it will be getting easy for you. Okay, so this is what they are saying. Okay, so this capacitor, I wish it was explained to me like this. Let's look at resistors. It's a device that opposes the flow of current. In a circuit. Resistor is a device that opposes the flow of current in a circuit. Resistor is a device that opposes the flow of current in a circuit. Class, Ohm's law. Ohm's law is the one that told us and gave us the relationship between the voltage and the current. According to Ohm's law, the potential difference across a plate is directly proportional to the current flowing through. And the constant that comes in is the resistance, R. So that V equals to IR. That is Ohm's law that produces popular formula. V equals to IR. Where V represents the voltage, I represents the current, R represents the resistance. Class, just like we did capacitors and capacitance, we have resistor and resistance. A resistor is a device that opposes flow of current. But the ability of the resistor to oppose flow of current is called resistance. The ability of resistor to oppose flow of current, resistance. Class, resistance, there are some factors that can affect the resistance of the resistor. You could be asked in the exam, which of the following factors cannot affect the resistance of the resistor? Class, the resistance of the resistor is directly proportional to the length. So the longer the wire, the more the resistance. And inversely proportional to the area. Please take note. The resistance of a resistor is directly proportional to the length, but inversely proportional to the area. So that a constant must come in, we know that now. So that R will be equal to resistivity is the constant that comes in. Resistance equals resistivity times length divided by area. There are actually three factors that affect resistance: length, area, and temperature. Please take the temperature. Note that increase in temperature increases resistance, while decrease in temperature reduces resistance. So resistance is directly proportional to temperature. Resistance is directly proportional to temperature. At higher temperature, a body will have more resistance. At a lower temperature, it will have lesser resistance. So resistance depends on temperature, length, and area. If ever you are asked which of the following is not a factor that affects resistance, please don't pick temperature, don't pick length, don't pick area. These guys affect resistance. Pick any other thing you see. Are we together? Are we together? The more we are together, the happier we shall be. The more we are together, the happier we shall be. The more we are together, the happier we shall be. So let us make resistivity. This symbol stands for resistivity. This symbol. The constant that came in is called resistivity. Let us make resistivity sort formula. Resistivity is RA divided by L. Resistance times area divided by length. Resistivity is resistance times area divided by length. Class, what do you need for resistance? Ohms. Resistance measured in what? Ohms. Resistance measured in what? Ohms. What's the opposite of resistance? If resistance is the opposition to the flow of current, what is the opposite of resistance? Someone should tell me. Conductance. Because we don't have time. If this was a normal class, I would have been giving you quiz, I would be testing you, but I'm forced to give you the answer fast. Opposite of resistance is conductance. For Jamb is too close, so there's no time. G is the symbol for conductance, and conductance is inverse of resistance. Conductance is inverse of resistance. Also, we talk about resistivity. We can also have more conductivity. What symbol for conductivity? The sigma symbol. Symbol for conductivity. And conductivity is inverse of resistivity. Conductivity is inverse of resistivity. Class, it's time to go to arrangement of resistors in series and parallel. Just like we did the arrangement of capacitors in series and parallel. Resistors can also be arranged in series and in parallel. Resistors can also be arranged in series and in parallel. This R1, this R2. This guy is R1, this R2. It's obvious that this series and this parallel. This series, this parallel. I want to give you a quiz. Class, if the unit for resistance is ohms, what's the unit for conductance? Resistance is ohms, what's the unit for conductance? Someone should tell me. If the unit for resistance is ohms, what then is the unit for conductance? Someone should tell me. Now, for internal resistance of a cell, class, apart from the resistance of the resistors, class, the cell can also produce own internal resistance. The cell can also produce what, but it's usually minimized, not as big as normal resistance. Class, you need to know called the electromotive force, EMF. The EMF is the sum of the what? Potential difference V plus the lost voltage. This V represents the potential difference. This small v represents the lost voltage. Class, this V is the current times the resistance. This small v is the current times the internal resistance, R. So that the EMF E equals to I big R plus I small r. You can see that this I here and this I here, we can bring out I and say R plus R. E equals to I into bracket R plus R. Please note this formula. Please note this formula. Let me get back to my arrangement of resistors in series and parallel. Class, just like we did in capacitors, you could be asked to find total resistance in the circuit for series arrangement and for parallel arrangement. Class, for series arrangement, you just to add them up, R1 plus R2. But in parallel arrangement, you find their inverse. 1 all over RT equals to 1 all over R1 plus 1 all over R2. 1 all over RT equals to 1 over R1 plus 1 over R2. Are we still together? I will not live to the end. I will not live till the end. I will not live till the end. Class, have you noticed that in resistors we're talking about currents? In capacitors we're talking about quantity of charge. What is the relationship between quantity of charge and current? Class, the quantity of charge is directly proportional to the current I. A constant comes in and you have Q equals to IT. Please take note. Quantity of charge equals to current times time. T is time. Quantity of charge is current times time. Quantity of charge is current times time. Class, you can also be asked to find the charge density. Or current density. The charge density is quantity of charge divided by area. The current density is current all over area. Charge density is quantity of charge divided by area. Current density is quantity of current divided by area. Very, very good. Someone has gotten it. The unit for conductance is Siemens. The unit for conductance is Siemens. So why the unit for resistance is ohms? The unit for conductance is Siemens. Why the unit for resistance is ohms? The unit for conductance is Siemens. Excellent. Well done. Well done, class. 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 Class. We did energy study the capacitor, remember? Class, when dealing with resistance, energy equals to current times voltage times time taken. Current times voltage times time taken. But don't forget that V equals to IR. V equals to I. So I can replace V with what? IR. I times I is I square RT. So energy can still be I square RT. But power, electrical power, is just current times voltage, IV. Current times voltage. Class. Coming back here, class. Are you aware that when resistors are arranged in series, the same current flows through them? The current in resistor 1 is same as current in resistor 2, and the same as total current in the circuit. If total current in this circuit is 2 ampere, class, the current flowing through each resistor is 2 ampere, 2 ampere because they are in series. But the voltage is different. But when they are in parallel, the voltage flowing through each of them is the same, but the current is different. Please take notes. Please take notes. So we have looked at electrical work done and power. Let's look at cost of electricity. Cost of electricity. Cost of electricity. Class, are you aware electricity is measured in kilowatt hour? Electricity is measured in what? Kilowatts hour. Class, you could be told in the exam that if the cost of electricity in a particular location is 8 kilowatt hour per unit. If the cost of electricity in a particular location is 8 kilowatt hour per unit, find the cost of running a 3000 watts appliance for 10 hours. If the cost of electricity in a particular location is 8 kilowatt hour per unit, find the cost of running a 3000 watt appliance for 10 hours. Class, 1 unit costs 8 kilowatt hour. And the cost, well, let me ask the question when I'm using my head. Let me ask the question away from your book. I'm using my head, so I'm supposed to give you the cost, the price. 8 kobo per kilowatt hour. 8 kobo per kilowatt hour, yes. If the cost of running electricity in a particular location is 8 kobo per kilowatt hour, find the cost of running a 3000 watt appliance for 10 hours. For every kilowatt hour, it's 8 kobo. What will be the cost of running a 3000 watt appliance for 10 hours? Class, you can see that the electricity is measured in kilowatts, not watts. You must first change this watts to kilowatts. How do you convert 3000 watts to kilowatt? Divide by 1. Divide by 1000. Take note. So you're going to have 3 kilowatts. Now you must change kilowatt to hour by multiplying by the number of hours times 10 hours. 3 kilowatt times 10 hours gives you 30 kilowatts. So 30 kilowatt hour of electricity was what is used to run this appliance. If 1 kilowatt hour costs 8 kobo, 1 kilowatt hour costs what? How much will be 30 kilowatt hour? We don't know, we'll call it X. We don't know, we'll call it X. Then we'll cross. X times 1 is X. 30 times 8 kobo. Because kilowatt hour will cancel kilowatt hour. So we have 30 times 8 kobo. X times 1 is X. 30 times 8 kobo will give you what? 240 kobo. If your answer is in naira, how do you go from kobo to naira? Kobo to naira is divided by 100. I know there's nobody here that met kobo. None of you are watching this video met kobo. That will be 2.40. 2 naira 40 kobo. 2 naira 40 kobo. This is the cost of running a 3000 watt appliance. This is the cost of running a 3000 watt appliance. Are we still there? Well done, class. Well done, class. Well done, class. Are you done writing? Are you done writing? I will not live to the end. I will not live to the end. Where are you? Where are you? I will not live to the end. Where are you? Good, good. Esther says still here. Esther says still here, sir. Still here, sir. Class, there are so many things, so many things. I'm just thinking of the ones that I should pick. We have what we call galvanometer. conversion of galvanometer to ammeter, conversion of galvanometer to voltmeter, what we call the Wisdom bridge, the meter bridge, the potentiometer. We have formula for a transformer, generator. These courses are so broad, but your examiner is only setting 40 questions. Some topics will not see chance. This is why I said, even as we are doing this, be doing 2 years of Jamb past question. As you, anytime you take a full year of Jamb past question, you have just covered your syllabus. Do you know? Because a full year of Jamb past question should touch every key aspect that the examiner should touch on the syllabus. Anytime you just finish a year of Jamb past question, you have finished what? Your syllabus. That's what you should know. Imagine doing 2 years every day. If you have not been doing it, I want to start tomorrow, Monday. I forgive you for the one you have not been doing. Please start it tomorrow, Monday. Because it's easier to do 2 years of Jamb past question than to go and read your full Jamb syllabus for each subject. Plus, from now till Jamb, they tell you to only read physics in Jamb syllabus. You will not finish. But you have physics, you have English, you have biology, or math, you have chemistry. Only one subject you cannot finish it in from now till Jamb. Now imagine 4 subjects. The smart student goes to the Jamb past question. This is why all our students are fully registered. I ensure to give you the Jamb master pass question. If you've not gotten your copy, I'll send it after this class to the private group. If you have not balance, I can send it to you. That's the key to your success. Your Jamb pass question is very important. Every day do 2 years. Anytime you solve 1 to 40 of a year, find out you must have learned a lot. Then you do correction. After every question, the solutions, right? Do your correction. You will see you'll be improving as someone that is trying to read chapter 1, chapter 2. Before that person gets chapter 10 in the textbook, Jamb exam has come. But you have been doing 2 years of Jamb pass question every day. You are more experienced than someone that read textbook. You are more experienced than someone that read textbook. I'm saying this because if we are being realistic, there is no way you will go that you will finish the full Jamb syllabus. It's too broad. Your teachers have proven to you that they can't finish it in 3 years. SS1, SS2, SS3. Me, I'll say the truth and I'll say it as it is. But what you can do is to be a smart Jamb student, a smart Jamb reader. Go to the key parts. Do your Jamb past question every day. Anytime you finish 1 year of Jamb past question, you have covered the Jamb syllabus for that subject. Do this for your first year. You can say today, set a timetable for yourself this week. Monday, I'm taking chemistry. 2 years. Tuesday, I'm taking physics. Wednesday, I'm taking biology. 2 years. Each day, 2 years. Thursday, I will do my English. Friday, I will do chemistry again. Another 2 years. You have not done 4 years in chemistry. Remember, anytime you finish a full question, you have done the full syllabus. It means that you have done chemistry 4 times for 2 years, 2 years. You have gone through the Jamb syllabus 4 times, 4 different years. It will build your experience. It will build your expertise. Anyone you don't understand, look at the solution. I'm just giving you a very powerful trick. This is not time to go to reading textbook. If you are still reading textbook by this time, you are not smart. How many things you can read? That thing you are reading, how are you sure that that's one that will come out? Only 40 questions in a very big ocean of topics. Only 40 questions. You have to be smart. Are we together? You will learn more from doing questions by question in your past question. In fact, everybody stop reading textbooks. Stop reading textbooks. Now, drop your textbooks. Just go to your Jamb past questions. Stop reading textbooks. Stop reading textbooks. Go to your Jamb past question. Simple AC circuit. Class, AC means alternating current. AC means what? Alternating current. Class, an alternating current, the voltage and the current are in different phases. There's what we call instantaneous voltage, which is V naught sine Wt. Instantaneous current, I naught sine Wt. Instantaneous voltage, V naught sine Wt. Instantaneous current, I naught sine Wt. Whatsoever we call the VRMS and the IRMS. Your VRMS is V naught divided by root 2. The IRMS is I naught divided by root 2. The VRMS is V naught divided by root 2. The IRMS is I naught divided by root 2. What is RMS? Means root mean square. The root mean square voltage and the root mean square current. What is V naught? V naught means the peak voltage. I naught means the peak current. Class, if you do 1 year of Jamb past question, you would have taught several topics. Because Jamb, 1 full year of Jamb question will not bring question for only one topic, right? It will test you in different parts of the physics, of the syllabus. You will come out with more experience than someone that has just written one topic since, or 2 topics. Imagine you now do 2 years. That means you have gone through the Jamb syllabus 2 times. Class, I think this is an inspiration. I just thought of this now. Please stop reading textbook. I work with inspiration. God guides me and directs me. I'm being told to tell you to stop reading textbooks. Go straight to your Jamb master past question or go to your Jamb past question. Start demystifying it. Start from there. Any question you are solving, anyone you don't know, check the answer. Solve. You will learn more than someone that is reading textbook. I'm saying it again because it's important. In fact, it's not even good for them to over teach you because how many things will you remember? Your brain will be too full. The time is very short. You have to be smart. There's what you do 3 months to exam and there's what you do few weeks to exam. This is not time to try to know everything. This is just time to pass the exam first. Maybe even after the Jamb, some of you that want to have a good foundation in physics, chemistry, can even be teaching you slowly. You see teaching slowly. Will not rush you. Teach you like your secondary school. We do your secondary school for you again. Before you enter university, when you enter university, you know what you have a strong foundation. But go and pass the Jamb first. It's the person that passed that I read though. It's the person that passed that is brilliant. Are we together? So I will also stop this class. I will also stop. Because I think we need a different direction now. We need a different direction. But at least give it the foundation you need to have. Peak voltage means the maximum voltage. Peak current means the maximum current. We also have what we call capacitive reactance and inductive reactance. Last, listen here. Book is broad, though. Book is broad. Book is broad. Capacitive reactance. This we have inductive reactance. Capacitive reactance is the resistance offered to the flow of current by a capacitor. Resistance offered to the flow of current by a capacitor. Resistance offered to flow of current. Inductive reactance, the same definition, but by an inductor, the resistance offered to the flow of current by an inductor. Inductive reactance, resistance offered to the flow of current by an inductor. Inductive reactance. Inductive reactance, resistance offered to the flow of current by an inductor. Someone said no questions tonight. You go and that's what you go and do in your jam pass question. I like the someone said 2 past questions this night. That is good. As soon as I release you, go and start looking for electricity questions. As soon as I release you, go and start looking for electricity. Use my jam master pass question. There is a solution for every question I give there. Use it. Look at the solutions. Be solving. Go and look for electricity questions. As soon as I drop this pen now, go and take electricity questions and be solving. And be solving. And be solving. There's a limit to how many questions you can take care of. Just burning your data and time is going to be sleepy. But you can go and do it in your question. Look for electricity questions and be solving. And be solving. Resistance offered to the flow of current by inductor is inductive reactance. What I'll do is that by Friday, this new week, this Friday, and every question that you are having challenging with, after doing your past session, you will not understand it. I will open the group up. Everybody post your question. Then we will come live and solve. Does that make sense, class? First, go to your past questions. Go to your jam question. Look for electricity questions. What topics you have done, look for questions under them. I will together. Anyone that you do not understand the solution, snap them and keep. I will open the group on Friday. Everybody will post. I will look at them, then I can still resolve them with you. Does that make sense? Is that a good plan? We're going to do that. We want you to pass. We want you to pass. Capacitive reactance FC is 1 all over 2 pi FC. Inductive reactance XL is 2 pi FL. We can spend 5 hours here and we'll not still finish the first syllabus. It's just too broad. FC is 1 over 2 pi FC. SL is 2 pi FL. But tomorrow we are starting biology, mathematics, and literature. Tomorrow we are starting biology, mathematics, and world literature. As soon as I drop this marker, I will create the group and post everywhere. Join the group that you are offering. At least have idea of biology, have idea of mathematics. Whoever is doing literature, only join the group you are doing. Join the group you are offering. This is for art students, obviously. This is for art students. This mathematics group, this biology group. Kicks off tomorrow by 8 p.m. There will be a group for biology. There will be a biology. We have a biology teacher. She's a female. We have a biology teacher. We have a mathematics teacher, and we have literature. We have literature. Yes. We also have what we call impedance. Class, in a circuit where you have resistor, inductor, and capacitor, RLC. Class, R represents resistor, L represents inductor, C represents capacitor. The total resistance offered to the flow of current is called impedance. Total resistance to the flow of current. Impedance. Total resistance to the flow of current, impedance. And Z equals square root R squared plus XL minus XC all squared. Class, there are so many formulas. There are so many formulas. Z equals square root R squared plus XL minus SC all squared. Z equals R squared, square root R squared plus XL minus XC all squared. Someone said, I like this plan. Thanks, sir. That's the energy. That is the energy. I like this plan. Thanks, sir. Don't forget, on Friday, I'll open the group. Help me post any question I was giving you challenge when you were doing your past question. Sir, I saw the solution, but I don't understand what they did. Keep it for me. Keep it for the jam master. Keep it for... Sir, when I was doing my jam pass, this were the ones I don't understand. That will tell me that you did your past question. That will tell me that you did your past. I will know those that did their past question. On Friday, I will open the group. Everybody drop your questions. Sir, this one I did not understand. Let me handle them. The tougher ones. Give me the tougher. But I'm giving you an assignment now. Everything we have done, go to your past question and take enough questions. Cook yourself in enough questions. Check the solutions. Every day, 2 jam past questions should go down. Don't open your TikTok from now till Jamb. Don't touch TikTok. There is no time. There is no time. That 1 hour you spend it. You see that the topics are so much. There is no time. So class, we're going to call it a day here, and you go and do what I asked you to do. Too much of learning close to an exam is very, very bad. You learn small, you go to the exam questions. If you have finished paying, you've not gotten your pass, you should message me this night, this minute, let me send to you now. So I've finished paying, just send for me. I'll add you to our private group and I'll send you the pass question. Go and do what I asked you to do. I give you an assignment. Go to your, in fact, go and burn the midnight candle. Burn the midnight candle. There's no time to sleep. Open your Jamb pass question. Go and start looking for questions. Start solving. Every day, 2 years of Jamb pass must go down. Don't be happy with yourself if you don't do 2 years every day. Now we have classes by 8 p.m. Biology, math, literature. You should plan your timetable in such a way that it doesn't clash with the class. Okay, tell yourself, okay, in the morning when I wake up, I will do past question. By 12, I will do another year. So that in the evening, I can now come for class. Plan yourself very well. I wish you guys the best. This will be your life jam. Please put in all your effort. Fight for it. Fight for your medicine and surgery. Fight for that course you want to apply for. Fight for it. I wish you all the best. See you tomorrow for our next subject. See you tomorrow. See you tomorrow. Thank you. Eze Joma said, I love the way you teach. Thank you. Thank you. Thank you. Thank you, everybody. Thank you, everybody. Good night.